Lesson 6.1, Perpendicular and Angle Bisectors. A perpendicular bisector is a segment that is perpendicular to and bisects another segment. So there's a segment. There's the perpendicular bisector. See, it makes a right angle. And these marks say the two ends are the same length, so it's right in the middle and perpendicular. Perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So that point is on the perpendicular bisector. The theorem says it's the same distance from each side. Hey, let's say why. Well, these two triangles, they share this side, and these are both right angles, which are congruent. So the two triangles are congruent by side, angle, side, which means that the hypotenuses are congruent by CBCTC. The converse of the perpendicular bisector theorem is also true. If a point is this equidistant, or the same distance from each end of a segment, then it is on the perpendicular bisector of that segment. Let's try an example. In this diagram, line JK is the perpendicular bisector of segment NL. Find NK. So we want the length of NK. Since JK is the perpendicular bisector, that means point K is on the perpendicular bisector. If it's on the perpendicular bisector, that means that it's equidistant from the two ends of the segment. So that means NK equals KL. Well, NK is 6x minus 5. KL is 4x plus 1. Let's get the x's together. Add the 5. Divide by the 2, so x is 3. Now, does that answer my question? No. I have to plug it in. NK is 6x minus 5. Well, 6 times 3 is 18, and 18 minus 5 is 13. So NK is 13. And if you're curious, if you plug a 3 into KL, 4 times 3 is 12, plus 1 is also 13. All right, Y is point M on JK. Well, notice point M is the same distance from N and L. So if a point is the same distance from each end of a segment, then it is on the perpendicular bisector. So M is equidistant from N and L. So M is on the perpendicular bisector. That is the converse of the perpendicular bisector theorem. And if you're curious, the first problem was just the perpendicular bisector theorem. Why don't you pause this video and try number 6 from your homework. The other part of the lesson is on angle bisectors. An angle bisector is a ray that bisects an angle, as the name suggests. So there is an angle. That is the angle bisector because it goes right between the two angles so that it makes two congruent angles. The two halves are the same length. That makes it a bisector. So the angle bisector theorem, just like the perpendicular bisector theorem, says if a point is on the angle bisector, then it's equidistant from the sides of the angle. So there's our point on the angle bisector. So it's saying that the distance to each side of the angle would be the same. Now remember, you measure distance perpendicular, so both of these are perpendicular to the sides of the angle, and they're the same length. We also have the converse of the angle bisector theorem that says if a point is equidistant from the sides of an angle, then it's on the angle bisector. We could prove the first one, to prove the angle bisector theorem. If we look at the two triangles, let's change color. So if I look at this triangle here and this triangle there, we've got right angles that are congruent. We have these angles that are congruent from the bisector, and they share that side. So the triangles are congruent by AAS, which means that the other sides, that are the distances, are congruent by CPC-TC. Let's try another example. Let's find the value of x. Notice from this point, that is the same distance to each side of the angle. If that's the case, then by the converse of the angle bisector theorem, it's on the angle bisector. So that means that that angle and that angle are the same size. So 3x plus 5 would have to equal the 4x minus 6. Let's get the x's together. Add the 6. So x is 11. Let's try another. All right, this time we know that we have the angle bisector that's given. So that means this point has to be equidistant from the two sides of the angle. So this is just the angle bisector theorem. But either way, we can say the 5x equals the 6x minus 5. Get the x's together, so negative x equals negative 5. Divide by a negative 1, so x is 5. Pause this and try number 14. Hope you got number 14. Let's try another problem. Do we have enough information to conclude that QS is the perpendicular bisector for angle PQR? So let's see. Well, they appear to be the same distance there, but wait, how do you measure distance? You measure distance perpendicular. Are these two segments perpendicular to the sides of the angle? No. So the answer is no. The distances are not perpendicular. Pause this and try number 10. Our last type is to write an equation of a perpendicular bisector. Well, since it's a bisector, find the midpoint. And you could do that by using the midpoint formula. Midpoint formula, remember, was x1 plus x2 over 2, comma y1 plus y2 over 2. So that's the midpoint. The slope would be the next thing you'd have to do. Slope is y2 minus y1 for x2 minus x1. Find the perpendicular slope. Remember, that is the negative reciprocal. And then we write the equation using the slope from number 3 and from the point from number 1. Remember, you go y equals mx plus b. You fill in your point for x and y, your slope for the m, solve for b, and then you write your equation. So let's write the perpendicular bisector of a segment with endpoints d and e. So start by finding the midpoint. I'll call this x1, y1. The other point I'll call x2, x2, y2. So x1 is 5, x2 is negative 11. y1 is negative 1, y2 is 3. So that gives me my midpoint of, see, 5 plus negative 11 is negative 6, and 2. So that looks like it's negative 3, 1. So when I go to find my equation, that'll be my x and my y. Now my slope is y2 minus y1 over x2 minus x1. So that's 4 over negative 16, which is negative 1/4. So the perpendicular slope is the negative reciprocal. Since it was negative, we're now positive. And the reciprocal of 1/4 is 4 over 1. So it's just 4. So I'm going to use this as my point, x and y. I'm going to use this as my slope. So then I have y equals mx plus b. My y is 1, my slope is 4, the x is negative 3. 4 times negative 3 is negative 12. Add that, you get b is 13. So our equation is y equals mx plus b. Why don't you pause this and try number 20.